Hello. This is the first topic in AP Chemistry. This is the study of chemistry, classification of matter by me, Samantha Warsaw. And then this is not really, we're not talking about the phases of matter, but this is an example of matter in all its phases with some hearts because I love matter so much. Okay. Here I have different types of matter again. So our first type is a pure substance. Now, this refers to either an element or a compound, which for me I kind of thought, when I hear it, I kind of just think of an element because I think it's just standalone by itself. But it can also be when it's combined with other elements. It doesn't. Excuse me. It can be both. So it can be any element, and so some elements like gold and copper were the first two I thought of, but really any element on the periodic table. And then a compound. So example of a compound is water, H2O. And you can see here's the compound here, all mixed in. And here's the pure substance where all the atoms are the same. So then going further into the definition of an element, a substance that contains an equal number of protons for all the atoms. So that is for an element. And what I was trying to get at with this second sentence is you can have a different number of neutrons, which isotopes are just element samples with a slightly different number of neutrons, because sometimes that just happens. But the number of protons will remain the same because that is kind of what defines an element. The same thing with electrons. You can have different numbers of electrons, perhaps with like different charges for an element, but the number of protons will always remain the same. So, because it relates to the atomic number, and that is kind of a little bit how you define an element. So that's good to note. And then here's our periodic table with all the elements on it, and you can see the number of protons will remain the same for every single sample of that element. And now to the definition of a compound. A compound is a relatively stable combination of two or more chemically bonded elements in a specific ratio. So obviously examples of water include H2O, where there's always going to be one H and two O's, or like carbon dioxide, where there's always going to be one carbon and two oxygens, or literally any, like you can think like carbon monoxide and all the other compounds like that. And this relates to the law of definite proportions, where the same amount must be given, the same ratios must be given for each type of compound, because otherwise it would just be a different compound. So then mixtures. Mixtures consist of two or more substances. So there are two different types of mixtures that we will be talking about. The first is homogeneous, and the second is heterogeneous. And you can see here, there's the little picture, and you can kind of read the words, but not really, because I'm about to go more into it, so I let it be cropped out in this heart, this beautiful heart. So, yeah. So, what is homogeneous mixtures? Homogeneous mixtures are mixtures where it's uniform throughout. So it's kind of like you could take I'll go through the examples first. Like air, seawater, and a nickel coin. So I could take I feel like I might sneeze. Sorry, I'm tired. Ugh. I could take a sample of air, and it's kind of going to have everything in it that it would already have, like nitrogen, oxygen, carbon dioxide, the other one, it's gonna kind of have a bit of everything, and it's gonna kind of look like this, like evenly mixed out through it. The same thing with seawater. It's gonna have like the same amount of salt mixed into water everywhere. And then with the nickel coin, same kind of thing with all the different types of elements and stuff mixed in within a nickel coin. Heterogeneous mixtures vary in textures and appearances throughout the whole mixture. So an example of this is like stew. Like you could have like, for example, my mom's chicken stew. You have like your pieces of chicken, your potatoes, and your carrots, and they're just like big blocky objects that don't mix together, and it kind of looks like this. They clump together the different types. They're not really, the atoms are not really mixed together. Yeah. So now we're going to move on to some questions where you're going to determine whether it is a heterogeneous or a homogeneous mixture. This is just good general base knowledge. There wasn't really any questions about it on the AP exam, but like it's basic review knowledge. So our first thing is Kool-Aid. Is this a heterogeneous or homogeneous mixture? And what you have to consider here is the distribution of the Kool-Aid packet into the water. And you can see here, this is the image of what you're basing it off of. Although it would most likely, in almost every case, it would be the same answer if you just were to imagine it. Unless you're imagining wrong. So I'll give you a few seconds here to answer. Okay. Homogeneous. So if you go back to this slide, that is kind of how it's mixed in. You can tell because the whole thing is the same color and the Kool-Aid packet is all mixed in. Like you're not going to take a sip and have like a really flavored Kool-Aid packet and then take a sip and have it be water. It's kind of all going to taste the same because it's homogeneous and all mixed together. Our next example is dirt. Is this a heterogeneous or homogeneous mixture? Again, think about that distribution. I'll give you a few seconds. Okay. Heterogeneous, because think about this, it's going to have like rocks. It's going to have different elements in it. It's going to have different minerals in it, and they're going to be large, clumpy objects that are not going to mix together, and it's going to be just one big, huge little mess. Okay, air. Is this a heterogeneous or homogeneous mixture? And I did talk about air before, but to see if you can remember and think about it, because this one for me, for some reason, always throws me off. And this is this lovely image I have here of it. So I'm going to give you a little bit less time because you should kind of already know. Okay, this is homogeneous because all the different things that are in the air are kind of intermixed with each other. They're not like, it's not like you're going to have a section of like nitrogen, a section of oxygen, and like take a sample and it's going to be different. It's kind of all mixed together. I think of it as like if I was holding, for some reason I'm thinking about it as if I was like holding like a cup and I just like was to take a sample of it. It's going to be the kind of the same if I took a sample of this, which means it's homogeneous. I'm not going to have like a cup and be like, oh, this one's mostly nitrogen, a cup, and this one's mostly oxygen. And that's what I think about for most things to determine whether it's homogeneous or heterogeneous. Because I'm taking a sample of dirt, it's going to have a bunch of things mixed in it. And if I'm taking a sample of Kool-Aid, it's going to kind of basically all be the same, no matter where I'm taking it. So this is the end of the slideshow. It's a relatively easy first section. And I didn't realize I was like out of the camera, but thank you.